Okay guys, what's going on? Hey, how y'all doing? Alright, welcome to our video on 3D printing. You have to excuse me, I'm wearing my no sleeve shirt today and my hair is a little crazy because it is hot in my house. My air conditioner condensing unit actually went so whew, it's been hot. I got parts on order though. Parts are coming, so I will be repairing that before too long. I don't know, I may even shoot some footage of it just to show you guys. In fact, actually I have it right here. This, whoops, losing pieces here. This right here. This little cheap, chunky cereal board right there. That little, you can't see it, it's a little dark, but all the lighting's over here. But anyway, this crap little, you're gonna see me rant is what you're gonna see. This little board, okay, I don't know, those of you that don't know anything about heating and air systems, this is a delay circuit board, which all it is you're just using an RC constant to delay turning the unit on. What that's for is so that you don't slug the compressor when it comes on. Like if you have a power blip or something, you have to wait for the compressor to equalize pressure before you can turn it back on, and that's what this does. Yeah, this board probably, look at it. It's like single-sided. Look at that, single-sided, all through hole parts. This probably would cost like maybe $10 to make, but yet it's super expensive. But anyway, enough of that. We're in a 3D printing video, so let's get back on topic. But yeah, just excuse the no sleeves, like complete redneck look going on here because it's really hot in this house. Anyway, so hopefully those parts will come soon and I'll get back to my normal shirts. Anyway, 3D printing. I promised you a video, here it is. So we've got our 3D printer. We'll be doing some more close-up shots of this thing. Anyway, I've been playing with it. Like I said, I wanted to kind of hold off on making this video because I wanted to play with it quite a bit before I start showing you guys how it works. I want to basically learn it and kind of get a grasp on it because I've never 3D printed anything before. So I have zero experience. Well, not now, but when I first started, I have zero experience with 3D printing. So it is all brand new to me. So hopefully it'll be brand new to some of you. This may be old hat and I can get some tips from you guys out there. Leave them in the comments. But anyway, main thing is we're going to watch how to set this up, just like the title tells us of this video. We're going to set one of these up because I've actually had to clean the extrusion head, and so I had to actually kind of take it out to get it all cleaned up and whatnot and put it back in. Whenever you do that, it's going to be basically not in the exact same spot, so you're going to have to recalibrate it to get it back where it's printing perfectly again. So I figured this would be a great opportunity to shoot a initial setup video because when it comes from the factory, it has mainly everything is pretty well calibrated and pretty well set up, but the kind of little fine-tune adjustments need to still be made on it. So you will go through this similar process when you get it. If you were to buy one of these brand new, pull it out of the box and hook it up, you'll still have to do just a little fine-tuning. I'm actually very impressed with the Printrbot Metal Plus, which is what this is. That's the model. This is a Printrbot Metal Plus. And I'm very impressed at how it was actually fairly easy. Like, you just pull it out of the box. And there was a couple things to watch out for, which I'll let you know that once we get into this. But more or less, you pull it out, run a few test prints, do a little minor tweaking with the calibration so far as the print head to the bed and distances and offsets and things like that, which nothing too complicated, so don't get scared, but nothing real complicated, just some simple little tweaking you have to do, and then this thing takes off and starts printing. It was actually pretty cool. Ran into one little snafu, which hopefully I will have on this video, so you guys, if you ever run into this, would be a problem. I think this is probably a 1 in a million thing that could happen, but still, it could happen to you guys, so it's worth mentioning. So anyway, what I'm going to do, this basically up here, this thing that's holding the spool and whatnot, this does not come standard with it. But that's the great thing about 3D printers. What's so awesome about these is if you don't have something like a cool spool holder, you make it, you print it. It's fabulous. I mean, this thing's amazing. So what I did was I noticed that sometimes this spool, at least this specific one, would get hung up if I just let it set on top here, because you can let it set right on top here and it'll pull it off. But if you have any type of, you know, plastic burrs or lips or anything, like in fact I can feel one right here on your spool, it can get stuck and hang up here. Now generally the little stepper motor is fairly strong, can pull it anyway, but you know, if you got a pretty good sized burr or something, it can get stuck, and then it cause the print or the extruder to get stuck, and so basically it'll just stop printing essentially because it can't extrude the plastic because it can't pull it. So I built this, I 3D printed these two side pieces, and now I mean I probably need some other work to do. It's a little wobbly, but honestly there's nothing real crazy going on. I mean, it's not like going at the speed of light or anything, so honestly I've really never seen it sit here and wobble and cause a problem, so it works for me. There's many other things out there, different websites that you can download stuff from that is like spool holders and whatnot for this that people have designed. So to each their own, but I went ahead and made my own and got the spool up off of the metal to where it's free and clear, so the head can move back and forth and everything work real well. So anyway, so that's the only add-on, guess you'd say, that I made for this thing so far. So anyway, well, and there's another piece, and I'll show you that here in a minute, but that I made is like an add-on. But anyway, we're going to go ahead and get into this. What I'm going to do is I'm going to take the camera and reset up. I just kind of wanted you to see kind of the whole thing, see how big it is and whatnot in this view, and plus I wanted to kind of announce this video. So I'm going to reset up the camera. We're going to get some software going, and I'll show you how to calibrate this thing, all right? So stay with me. Okay guys, let's get some software fired up for you. What I've got for you today is this is one of I think the greatest 3D modeling softwares. There's lots of free ones out there. This one is called Cura. It is made by Ultimaker, which is actually a very good machine as well. But what's awesome about the folks over at Ultimaker is they embrace the maker community. They really do. And what they did is they actually created their software for a whole host of different printers out there. The minute you download their software, it will actually ask you what kind of printer do you have. Even if you don't have an Ultimaker printer, this software will actually work with multiple different printers. I mean, there's a whole bunch of them out there that it'll work with. And one of those is Printrbot. It'll work with the Printrbot printers because most all printers have one form of G-code or another. There's what's called G-code, which is the tooling code that has the tool path, basically the code of where to move the head during the printing process. That's all called G-code. And there's different formats of the G-code, and basically Cura, the software here, can do many of the, if not all of them. I don't know. I haven't really researched it a whole ton, but it does many different G-code formats. So therefore, it can talk to many different printers. So based on what kind of G-code that it accepts. So and one of those, like I said, is the Printrbot. So when you first install Cura and you launch it for the first time, it'll ask you what kind of printer you have. So of course I chose Printrbot, and then it asks you which model, and I chose the Metal Plus. Now you could have the simple metal as well, and you can choose that. So it supports all of Printrbot's printers. So anyway, you'll choose which one. Now there's a couple of other settings that you need to make once you have the software up and running. Now what that is if you go to, let's see if I can remember this, machine settings. Oh, it popped up on my other monitor. Let's drag it over here. In here, see, here's the G-code flavor. So this is basically the format. You just leave it as default. That's what you want, is the riprap. Let's see, I think this is it. Extruder count. This is where you would select if you have multiple extruders. I know the Printrbot Metal Plus can support up to, I believe, 3 extruders, which is pretty darn awesome. But you can choose that here. You can check mark if you have a heated bed or not. Now, I got just the standard Metal Plus, so I don't have the heated bed. or anything special like that. So mine is just a standard, no heated bed, single extruder, just plain Jane one. Now maybe down the road I'll probably end up putting probably dual extruders on it, actually, just because you can do some really cool stuff, and I may talk about that later, but you can do some really cool stuff with dual extruders, as well as I may put, definitely the first upgrade I'm going to make to it is the heated bed. It just helps with adhesion, basically, because you have to get the plastic to stick. It's got to stick to something. We'll go over that here in a minute when I show the setup of the actual printer itself. But you need to get the part to actually stick to the bed. Otherwise, it'll peel up while it's printing, and it'll cause all kinds of problems. So you want to do that. Now, if you have a heated bed, kudos, because that helps a lot. You can print ABS, because if you're going to print ABS plastic, it has to be a heated bed, because there's no other way. ABS is a very high temp plastic to extrude, and which is great because you can do it in high temperature applications and things like that, where higher temperatures can be reached without melting the actual plastic enclosure or part or whatever you're doing. But also because of that, if it touches a steel bed, which is what this is made out of, that's really cold or room temperature, it'll harden too quickly and it won't stick to it. It'll just pop off and have, and then you'll have a failed print. So anyway, that's where you set that stuff up. My settings are as such. And then there's one other settings that you have to do, which I got to remember where it is. I think it's under Preferences. If you go to File and under Preferences, well, and it opens over here. All right. Yes, this is what I want to say. You want to do the printing window type. You want the Printrbot UI, however that's pronounced, Printrbot, whatever. Normally it's set to basic. You want to change it to Printrbot. What that will do is give you what you're about to see here in a minute. I'll show it to you. Is it will give you the control display where you can basically move the head. You can set the bed temperature. You can issue it G-code commands, which is what we need to do to set it up initially. Once you get it all set up, it saves it. It has its own microcontroller that's on board. Its own firmware and everything. It has its own EEPROM. You can set the settings, and it will actually save in the printer itself. So you don't have to save it like locally on a PC or something like that. It actually saves on the printer itself once you get it calibrated. But anyway, to do that, you want the Printrbot UI is what you want to use for that. So we'll make that setting. Now we just need something to print. I'll go through quickly some of the stuff that's in here. You've got a basic, advanced, and plugins, and a start and end G-code tabs here on Cura. So most everything is set for default. However, there is a profile that's out there. I'll put a link in the description. But there is a getting started profile, which has basically it sets it up for the different temps and other settings that you may not be accustomed to being new to 3D printing like I was. So that really helps. How you load that is you go to File, you go to Open Profile, and like I'll have it here, which I've got. Let's see, I'm on all my Printrbot junk. I've got one for settings. I've got a few different settings. I tweak them, and that's another thing that's really cool is that let's say you run different plastics or different materials, like you maybe run the Ninja Flex, or you run ABS, or you run that one that's like wood, which is interesting, or you run any of the different types of materials. You can set up a initial starting point setup for you based on each material, because each material has different settings, so it's actually that's kind of a cool deal. So it's the getting started one. What that will do is that will set this guy up, usually give you a temperature of about 210, a print speed of about 45 millimeters per second, which that's probably okay, and then it'll also give you the fill. Now, what is the fill? The fill is the thickness, obviously, as it goes, so how far it moves up in the z-axis while printing, that's part of it, as well as the fill density. If those of you that don't know, a 3D printed part, which we'll see in a minute, I'll show you, a 3D printed part, you could make it solid plastic, where it's solid plastic. The problem is it takes forever to print, and if you want to print quickly, or you don't really care about it being solid. It can be just, fairly stout, but it doesn't have to be 100% solid. You can lower the fill density, and what it will do is it'll create actually an internal lattice work inside the part, instead of literally, millimeter by millimeter filling the entire thing in completely solid plastic. It will build basically kind of like a lattice work inside, and we'll see that here in a minute once I get a part loaded in. Quality is the layer height, shell thickness, and if you want to enable retraction or not. Let's go through these one by one. Layer height in millimeters means how far or how thick each layer is, because as you know, this is what's called a slicer software. As you know, for 3D printing, it takes a 3D model and it actually cuts it up in basically the z-axis. It slices it into thin little cross sections, and then that's how a 3D printer prints. Is it prints each cross section layered right on top of each other until it ends up printing the entire thing, entire 3D model. So this is telling you how thick it needs to be, or how fat or how thick each layer needs to be. And so if you want high quality prints, you're going to lower this, lower it all the way down to like 0.1 millimeters would be like super high quality, or at least the highest quality that your specific printer could probably print. Okay, so you want, if you want super high quality prints, but there's not a lot of lines, or you can't, the lines aren't as thick, or noticeable in the print, you want to lower that down, and that'll cause a higher quality print to be made. As well as shell thickness. Basically, like I said, when you're doing a fill density less than 100%, it's basically creating a shell with a lattice work inside. So how thick do you want that to be? So that's another quality thing. It could be, if it's too thin, it could break easily. So you want to take that into consideration. Enable retraction. What retraction does is it helps to cut down on stringing. Okay, the stringing effect is where remember, this thing is like squirting plastic out like out of a syringe is how it's kind of working. So when you squirt the plastic out, if you move real quickly while you're squirting the plastic out, it's going to string. You know what I mean? It's going to, I don't even know how to explain it without showing you. But it's going to string, it's going to stretch. The plastic is going to stretch from one side to another. So if you have, let's say, one part right here, and then the next part's over here, if you have it where it's moving really fast, it could, while it's squirting the final piece of plastic out here, when it picks up and moves over to the next part, it'll actually string plastic to the next part. So what you want to do is you can enable retraction. And what it will do is the extruder feeds the plastic into the hot end, is what it's called, so into the actual thing that melts it. And what it will do is it'll actually pull back. It'll actually, instead of pushing the plastic into the extruder, it'll actually pull the plastic back out of the extruder by a certain amount, which in the advanced settings you can set how far it pulls it out, and how fast, and all that stuff. How far it pulls it out of the hot end. And so what that'll do is that'll help kind of like suck the plastic up inside of it, so that way when it moves, it will basically break any strings, and it won't actually stretch from one part to another, or one side of the part to another. So anyway, that's another setting you can play with. Well, enough of the settings. Let's go ahead and load something up. Let's grab the basic 3mm box. Okay, so what this is a little tiny square of plastic is all this is. That way it only takes 8 minutes to print. And that's another thing that's really cool about Cura. Of course, Cura is the only one I've used, and one of the ones that I've watched other 3D printer people use on YouTube here. And I really, so others may do this, but I really like this one. It tells me it takes 8 minutes. It's only 0.33 meters or 1 gram of plastic. So if you're working on maybe selling these pieces and parts and things like that you print, or you're going to start maybe some sort of a job, 3D printing parts and whatever, you can actually get an estimate on, how much plastic it's going to take to do one of these. And so that way you'll be able to charge accordingly. It's kind of a slick deal. So now, remember me telling you about it creates layers? If you go up here to this view mode, I can choose layers mode. And now it's going to show me, it looks like there's about 15 layers that it's going to have to make to build this part. Well, I can click it and I can drag these layers, and you can see what's inside. See the lattice work? See that? That's the lattice work that I'm talking about. Now, if I were to take this fill density and crank it up to 100%, that's going to be solid. See, it's just going to be a solid plastic part all the way through. Okay? But if I lower it down, let's say 50%. See, the lattice work gets more dense. See that? The lattice work will get tighter as you increase your density. And like if I send it down to 20, see, now it spreads the lattice work out. So that's how we do it, and 15 is great. And of course, it will update your how long it takes to print. So if we did it at 100%, it's going to take double the time. It's going to take about 16 minutes for it to print. Okay? Because obviously it's got to sit here and fill all of this in, edge to edge, corner to corner, top to bottom. Okay? So since we don't really care, we're just doing this as a test print, we can put it at 15%. And so it makes a pretty good thick border, and it makes pretty good little lattice work in here. So that's what it's going to do. Okay? And then this stuff out here, it always prints kind of like a little border. I think that's because the extruder doesn't just, especially if you go from like a cold start and you just fire this thing up, the extruder's not gonna print immediately. Like it takes it a while because it's got to heat up for one thing. Then it's gonna start, once it starts printing, it's gonna take a few clicks of the extruder to actually get the plastic to start flowing. It's got to basically kind of like pressure up to start the plastic flowing. So that's what these little lines are, is it goes around the perimeter and kind of gets the plastic flowing real good, and once it gets to flowing real good, then you'll see it scoot over and start doing the actual part. So I'm going to go back to normal view mode. Okay, so this is what's going to print, little box. Hooray. It's going to print it basically in the middle of the print bed. Okay, and if those of you that aren't real good with the coordinate systems, basically this edge is here's your basically your 0, 0 point right here. This little black kind of like tri-axis thingy that's right here in the corner. Basically this edge right here is 0, 0. Okay, so if you see anything, so anything that's in the X direction is this way, the Y direction is this way, and obviously the Z direction is up and down. Okay. So this is basically the front of your print bed and the back of your print bed back there. This is the left-hand side and the right-hand side, and of course the bottom and the top. Okay, is how that basically looks coming out of your printer. So now we're going to go ahead and say we're going to print this with USB. I have my printer connected, so that's how it knows that this will be grayed out if your printer isn't communicating or whatever. So we're going to go ahead and click this, and this is going to bring in that Printerface or Printer UI or whatever that's called. It's going to connect to our printer, and right now the temperature is 20 degrees because I don't have it turned on. So with this, you can actually home the Y, home the X, and home the Z. Okay. You can also cause the extruder to extrude. You can cause it to retract. You can cause the Z axis to go up and down by either 0.1 millimeters, 1 millimeter, or 10 millimeters. And everything is done in millimeters in this thing. So that's just the way it is. So what I'm going to do right now is I'm going to go ahead and I'll probably pop up a camera view of this guy right here, and then we will go ahead and take this guy and we'll start playing with it. So give me a second and we'll pop this up right here, and then we'll start playing with this guy. Okay, guys, this is gonna be interesting. I'm gonna try to go between one camera and the computer because I'm gonna have to get up and walk back and forth. But I got got this pulled up right here, and I had started to heat it up. So what you're gonna do to heat it up is you're gonna come here. You're gonna type the temperature 210, okay, and then it should start heating up like it did here. So, and this is kind of cool. You got this cool little profile that brings it up. And what we're going to do to get this is we're going to type M501, and yes, the M is capitalized, and it basically lists out all your settings for your system here. So we've got The one we want to look at is the bed probe offset. Okay, so that's the main one we want to look at. Especially the Z. This what tells us how close to the bed we're going to be. Now, you got to be careful when doing this because sometimes if you get it too close, you want to be very simple. You want to start high and go in very slowly. If it takes you, 30 prints to get it right, that's okay. You definitely don't want to crash it into the bed because it actually will. If you tell it to offset it too much, it will actually grind the head of the extruder into the bed, which will destroy the bed. It will tear up the extruder. It's a bad deal. So go very slow. If it happens to happen, make sure you have the power cord nearby and just quite literally, it's not going to hurt it. Just yank the power out of the printer to stop it from doing it if you ever run into that situation. Honestly, I did it. I did it myself. And yeah, I just yanked the power out of it. And Printrbot even says that. They're like, just pull the power. It's okay. It won't hurt it. It's not like an old 80s computer that'll crash. Just yank the power out of it. It'll be fine. So keep that in mind. So what we'll do is we start high and we start going low. So what I'm going to do is I'm going to go in by order of 1/10 of a millimeter. And this, by the way, this is all in millimeters, okay? Just like it says, it's in millimeters. So we're getting close. We're about to 210. Actually, I think I'm going to go to 195. Actually, I've been having better luck with 195 and a little bit slower speed. Has been doing me better. In fact, I'm going to load my profile that I know works. So we're going to go over here to open profile. We're going to go to settings, and black PLA is what I called it, which is about 195 with a print speed of 25. You can go faster. You need to turn the temperature up if you're going to go faster because you need it to be more gelatinous to be able to print well that way. So we're going to come in, pull our guy up, wait for it to connect. Once it detects baud rate, and now it's going 195 is what we're going to go with. But now I want to show you something over on the printer, some settings that you kind of have to do once you pull this thing out of the box. So we're going to go right over to the printer. So hold on just a second. We're going to maximize this window. All right, so here's what we're going to do to do like an initial setup of this guy. What this is this is actually blue painter's tape, believe it or not. A big thing that you have to do with 3D printers is you've got to get the plastic to stick. So you want the plastic to actually stick to the board. Otherwise, it'll pop off and it'll ruin your print and it'll get tangled up in the print head and it'll just be a mess. So what you want to do is blue painter's tape works really, really well if you don't have a heated bed. Now, if you have a heated bed, you'll have basically like a Kapton tape that's over the top of it, and it'll be heated, so you'll be able to, it'll stick properly and whatnot, and you can play with the settings and whatnot. But if you're like me and you have just the basic model that does not have the heated bed, blue painter's tape is your friend. And then in the instances where blue painter's tape, sometimes it'll still pop off with blue painter's tape, I use the one, the only, the Vidal Sassoon. All right, so hairspray, more or less. Hairspray. It works magical. It keeps your hair up, and cause plastic to stick to surfaces. It's multi-purpose, right? It's got a dual function. So all you do is pop some of this off and just hit it lightly. Now the key is, like I tell my kids when they use hairspray, you don't want to use it like this. Otherwise, you're going to get a little teeny tiny big globule mess going along it if you hold it like this. You want to keep away from it, good 6 to 8 inches. The further the better, and just hit it. And that's about it. Just a nice dusting is all you want. Let that kind of dry for a little bit where it gets kind of sticky, and then push go on your printer. So that's basically what I do to set up my printer. Okay? All right. Okay. All right. So what I want to show you is right around in here, you have this guy. Hopefully you can see that. Let me see if I can't zoom in. I'll zoom in a little bit. Maybe not a whole lot because I'd like to keep the camera where it's at. But see this guy? This is actually what's called a proximity switch, or a prox switch for short. What it does is this thing, as you can see, there's a little red light on. I don't know if you can see that. There's a little red light that's on up there. What this thing does is once it starts getting close to a metal surface, doesn't matter if there's plastic, paper, skin, anything in the way, if there's metal, this switch will detect it. And it detects it very accurately, and usually it's within only a few millimeters you have to come of this sensor before it will tell you that it detects metal. I've seen this used in industry, I've seen it used in plastic machines, metal punch press machines. I've seen this used in many different things that need to detect metal. And that's what it does to know that it's getting close to the bed here, is that it will detect it with this guy. Now, the cool thing is Printrbot gives you, let's see if I can find it. I had it setting out a little while ago, but looks like I have sat it below. Printrbot gives you a little leveling device that you can use with this. I've put mine up. I should have had it prepared for this video. Sorry about this, guys. But okay, they give you some tools, all right? All right, these are the tools that they give you, which is actually kind of cool. These are actually laser cut pieces of wood, which is interesting for a wrench. I mean, the only problem is that they do break after a while. Like, in fact, this one, you see that I've like chipped the chunk of it off, you know, whatever. So I mean, it's cool, but I mean, I don't know how useful it is. But you use these to adjust this, and what you want to do is they give you this piece of plastic. Excuse me. They give you this piece of plastic, and what you want to do is you want this plastic to be snug underneath. See, hopefully you can see that. Can you see that? You want this to be snug. Good grief, I'm coming in at a weird angle. Okay, you want this to be snug underneath here, but you do want it to pass underneath here. So you'll basically home your Z-axis, okay, and then basically play with this sensor till you get it to where it's right there. You know, that's what you're gonna do, okay? Now, what we'll do beyond that is we are now going to fine tune it. That basically course sets the bed level and lets you get close, you know, to it, but you may still be a few millimeters off, and that's where we're going to set it up in the software. So let's go back to the software. We'll shrink this screen down and we'll go back to the software. Okay, now that we're back to the software, we're heated up to 195 degrees. What I'm going to do, just to show you what I'm talking about, is we're going to go ahead and hit print, and we're going to watch this thing print. So we may take and maximize this. Sorry, we'll switch audio here, but we will maximize the window down here, and we're going to watch this thing print. And I'm going to try to see if I can't man the camera here, and I'll show you the problem that it's having. And you'll get to see that what happens is that it will, it's just not close enough. It'll pop off, you know. So hopefully you can see it. It looks like it even had a string too. If you can see that. See it getting kind of goopy? I mean, it's sort of kind of working. I mean, it's looking pretty good. I don't know, this camera is going to be hard pressed to capture it. But it's just not, you can tell when you look at it that it's very round. You want the plastic to be a little bit smushed, not a whole lot. Now you can smush it too much. You don't want it smushed too much, but you do want it to be a little bit squished, and it's hard to see here, but could do a super close-up here in a minute. It's hard to see, but you want it to be just a little bit mushed. You don't want it to be very round, because that means that it's not really pushing it down onto the bed, meaning it's not really squishing the layers together. And so you'll get some weirdnesses that can happen with it. So I'm going to back out. We're going to go ahead and stop this. I'm going to take and switch back to the computer now. Okay, so we're going to go ahead and click the cancel button. And so that should stop it. And then I'm going to pop this off of here. What we're going to do is, now that we're at the computer, I'm going to home the X and Y. Okay. And then we'll go back to the other one. So now what I'm going to do, usually you can do this with your fingernail. I'm just going to take and I may have to get my scraper. Oh, there we go. Pop this guy off. Okay. Pop him off the bed here. Whoop, there we go. Pop him off the bed. This is our test piece anyway. This one, I mean, you're going to do this a lot. So what I'm going to do is I'm going to bump this down just a millimeter. So let's go back to the computer. Okay. So what we're going to do is we're going to type our M501, get our list. And now what I'm going to do is I'm going to type, this is M212 is what this is. So I'm going to type M212 and then Z minus 0. I'm going to go with just 7. I'm going to go just 1/10 of a millimeter lower. Okay. Once you issue that, you have to save it. So you're going to type M500. That's going to save it. Now we can hit print again and let's go take a look. We'll maximize this. So now what this is going to do is this is going to reset up and it's going to print it yet again, but it's going to do it a little bit closer to the board. So we'll see what it does once it gets a little closer to the bed. So this is all you basically got to do. You just kind of hit or miss with all of this. You're just going to print and make it closer or further away and print again. And you're just going to do it over and over and over till you get a nice, good looking 3D print. Okay. So this is starting to look better. Let's get some zooming in action going on here. That's looking a lot better. I think that might be what I want. Sorry if I put my head in the way of the camera, but I want to look at this. Now that's looking good. That's looking pretty good. So let's see if I can, here. It may get wobbly, but I'm going to zoom out so I can get the camera closer. Sorry about this. I'm going to get all kind of wobbly and crazy. Let's see if I can't get the camera closer to this here so you can really see what's going on. These things are just absolutely amazing. I am just blown away every time I watch it print. It's just, I know how it works. I know what it's doing. It's just amazing. Okay, see, now here's one thing that I am still struggling with. This is where you guys can help me. Those of you that may be 3D printing experts, do you see this line right here? See that? See that little spot where it did not squirt plastic out? That happens. And I don't know what causes that. That drives me insane. It's hit or miss. Sometimes it happens, sometimes it doesn't. It just quite literally blows my mind. Now, I mean, like on this print, it's not really that big of a deal because what it's going to do is it'll go across it, see, like this. So it's not really going to hurt anything. But on larger prints, like ones that are like the whole size of the build plate, it'll do that. It'll skip like every other line, and it's absolutely maddening. It makes me nuts what it does. Well, anyway, that's basically how you're going to do this. And like I said, I think this setting looks pretty good. I kind of like what it's doing. So that's probably okay. So anyway, this will take 8 minutes or so to actually work. So while this is doing its thing and it's just absolutely noisy, I'm going to show you another thing. Show you a part that I had to make for this guy for some issues. If you notice, on the back of the extrusion head, there's this little black thing. This I 3D printed because the wires here are not strain relieved. Bad. That's the only gripe I have about this whole system, is that those wires are not strain relieved. They are not strain relieved properly. It's right up against the motor is where it wiggles. And I actually had a problem. A wire broke on me. A wire going to the motor broke. And it ruined the motor. And so, of course, great thing. Printrbot is wonderful people. Printrbot guys, you guys are awesome. I told them about this, that it wasn't printing right or whatever. They told me to troubleshoot it a little bit, wiggle the wires, see what's going to happen. Because what was happening was this part right here, this little extruder head, if you can see that thing's turning and pushing the plastic in. This thing would sit there and jiggle. It'd go, and it'd just jiggle it like it didn't know what to do. And it was because one of these wires back here was actually broke inside the motor. Now, when I got the new one and replaced it, I tore the old one apart and looked at it, and yeah, there was a wire inside that had broke. And so that was the issue. So just absolutely maddening. So what I did was I 3D printed this little part right here, and in fact, I think I'm going to replace it, and I'm going to put, there's a thing that's out there, who makes, I can't remember, somebody designed like a chain that goes back through here that holds all the cabling. That's like a chain deal that you can 3D print out. Another reason why 3D printers are just absolutely amazing. If it has a problem, you just 3D print a part to fix it. It has just got to be it's just the coolest thing like ever. I think everyone's got to get into 3D printing. It's just fascinating. But yeah, but what I did was I printed this part that basically has a hard, rigid tube, basically, that makes the strain relief, instead of being right up against the motor where it can break, it strain reliefs it way out here to where out here's wiggling, where the wires are less likely to break internally to the motor. So that's basically what I did to fix that problem. So if you have one of these that's jittering or jiggling or doing weird stuff like that, do the recommended thing and check and make sure you don't have anything clogged. But at the same time, check those wires, man. Wiggle those wires. Okay, as you can see, it's now drawing the lattice work. Like I said, don't want to focus. Come on. Okay. It's now drawing the lattice work. So see, it's not going to be a solid part. It's going to do exactly what the slicing software told us that it was going to do. And so there it goes. Pretty darn slick. So anyway, guys, that is basically the initial setup, literally. Now, one caveat, one thing, one gotcha that I do want to recommend to you guys, say don't ever, ever, ever do this, is their instructions that they have is basically they tell you to use the screws. Hold on, let me back out for a minute. It tells you, let me move this. Let's see, I'm going to scoot the camera over. Sorry for the jittering. It's going to get all bouncy. But basically, see the Z-axis threaded rod right here? This rod right here? That's what basically, there's one on this side and there's one on the other side here, and that's what moves this bed up. Okay, or at least moves the extruder head, it moves it up in the Z direction. They tell you, when you initially set this up, to spin these and screw these to move it down. What they're telling you is because on the Printrbot Simple Metal, which is what the instructions are about, that they tell you to go look at for this one, which, another gripe of mine, sorry, but that's not cool. You need to make instructions for this unit. And I know you guys are busy, so I mean, it's not a problem. Like I said, I love you guys, Printrbot. You guys are great. But the thing is you really need a set of instructions for this specific unit. Don't rely on that, well, it's similar to the Simple Metal, because it's not. In the Simple Metal, there's only one Z lead screw in it, the way that's designed. So yeah, you can spin this screw and move the head up and down, get it closer, whatever. I basically did what you guys told me to, against my better judgment, and it disaligned this whole thing. Basically, it was off. It was crooked because I had twisted this one more than that one, because it's really hard to do. These stepper motors are very fine, and so a little bit of movement here is a lot. And so it basically disaligned this whole thing. Now, the good thing about me is that I've got a whole bunch of precision measurement tools. I've got depth gauges and calipers and micrometers and things like that that measure down to like 100,000ths of an inch and things like that. So I was able to, using those tools, measure the distance between this and the bed and actually get it down to where it was pretty much perfectly level all the way across. Because what would happen is it would print fine over here, and then it would grind into the bed over here. So rough, bad deal. So do not follow the instructions when they tell you to spin these rods. Do not do that. It comes perfectly calibrated, perfectly level from Printrbot. Do not spin these rods. Use the software to run the Z-axis up and down. Do not spin the rods, because it could be a very bad deal for somebody that's new to 3D printing and doesn't have calibration tools. Okay, so anyway, that's basically it, guys. Hope you enjoyed this video. Looks like we're about done. Alright guys, well, there you have it. There is the little 3mm block that was made by our 3D printer. How cool is that? Well, guys, I hope you enjoyed this video. Hope some of you found it, the information to be quite helpful. Leave me comments down in the comments section. Hit the like button. That really helps out the channel. Tell you what, subscribe and share and all that jazz. And we'll be coming out with more 3D printing videos as I find interesting things to 3D print, as well as I think probably the next basics videos is that I'll even show you guys how to 3D model up parts and whatnot, and how to get that all going. So anyway, guys, take care. Hope you enjoyed this. Like I said, you can find me on Instructables, Twitter, all those different social sites and all that jazz. Hope you guys are doing good and having a good time. Keep building, keep on making, because that's what it's all about. All right, guys. With that ought to do it. Take care. We'll see you next time. 3D printers are cool.